Hello calculus students, and welcome to the second video for the AP Calculus AB math course here on Snowflake Learning. So in today's video, we will be focusing on the derivative function and the shortcut rules, implicit differentiation, position, velocity, and acceleration, and related rates. And again, we have Callie the Calculus Cat here to join us along the way. We have the derivative and tangent line problem. So the limit definition of a derivative here is f prime of x equals the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. And we can use this in different problems, such as this one here. Find f prime of x for f of x equals x squared using the limit definition of a derivative. So here we have our notation written out, and we have plugged in x, right? So here we have x plus delta x squared minus x squared, which is f of x, over delta x. And so when we simplify that, we get 2x delta x plus delta x squared over delta x here. And so the delta x's here, and here, they cancel out, and that gets us the limit as delta x goes to 0 of 2x plus delta x. And since this is just 0 and we can direct substitution that into there, our derivative will be 2x. And so just one point, if a function is differentiable at x equals c, then f is continuous at x equals c. And so now we have some differentiation rules. So basically, if you are taking the derivative of a constant, that will always equal 0. So for example, if f of x equals 20, then f prime of x will equal 0. We also have the power rule, which is basically where if you have a function that has an exponent or a power and you're taking the derivative of it, you're basically going to bring the exponent down in front of the variable here, and you're going to subtract that exponent by 1. And so, for example, here, if you have f of x equals x to the 4th, then your derivative will be 4x cubed. And so if you have a constant multiplier and you're taking the derivative of that, so for example, you have n times f of x, then the derivative will just be that constant n times f prime of x. So for example, you have f of x equals 5 times x to the negative 2. So f prime of x will just be 5 times negative 2x to the negative 3. And this was using power rule here. And further simplification gives us negative 10x to the negative 3. And so sum and difference, when you're taking the derivative of functions that are being added or subtracted, you just take the individual derivatives of each function and just add them or subtract them normally. So here, if you have function f of x equals x squared plus 5x minus 3x cubed, you just take these individual derivatives and just add or subtract them based on what the problem says. So f prime of x here is 2x plus 5 minus 9x squared. And so now the product rule, if you have two functions that are being multiplied by each other, like f of x times g of x here, you're first going to take the derivative of the first function and multiply that by the original second function. So that's f prime of x times g of x here. And you're going to add that to the original first function. So the function you took the derivative of first, now you're just going to take the original function and multiply that by the derivative of the function that you did not take the derivative of earlier. So in simpler terms, f prime of x times g of x plus f of x times g prime of x. So for example, if you have f of x equals x plus 3 times 3x squared, you're just going to first take the derivative of one of these. And so first we took the derivative of this, and so we left this as is, so we got 3x squared plus, so now we're going to leave this as is, x plus 3, and take the derivative of this, which is 6x, and so that's how you get your answer. And for a quotient rule, if you have one function divided by another function, you're going to take f prime of x times g of x minus f of x times g prime of x over g of x squared. So there's also a little saying. So it's low d high, as in the derivative of the top function, minus high d low, as in derivative of the bottom function, square the bottom, and away we go. So that's referring to squaring the bottom here. And in an example again, f of x equals 3x plus 5 over 4x squared plus x. So we have f prime of x, which is 3 times the bottom, and then so minus f of x, which is this top function here, times the derivative of the bottom function, which is this, and you just square the bottom. And so another big one is chain rule, and that's where you have like a function within a function, so f of g of x. So basically what you're going to do is you're going to find f prime first, so f prime of g of x, and then you're going to take the derivative of this inner function here, which is g prime of x, and just multiply it. So here, if you have f of x equals x cubed minus 2x to the fourth, so you're going to take the outer function's derivative, so in this case, it's this to the fourth power. So your power rule, you're going to bring the exponent down, subtract by 1, so that's 4, and then multiply by x cubed minus 2x to the third, and then multiply it by the derivative of this, which is here. And then some trig derivatives. The derivative of sine x is cosine x, the derivative of cosine x is negative sine x, the derivative of tangent is secant squared x, the derivative of secant x is secant x times tangent x, the derivative of cosecant x is negative cosecant x times cotangent x, and the derivative of cotangent x is negative cosecant x squared. Okay, so now some applications of derivatives in position, velocity, and acceleration. So the notation for position is s of t, and the notation for velocity is v of t or s prime of t, because velocity is the derivative of position. And acceleration will be a of t, which is also v prime of t, because acceleration is the derivative of velocity, or s double prime of t. And so here's an example. A particle is moving, so its position s at time t is s of t equals t to the fourth plus 3t cubed minus 6t squared plus 10t. So A, find its position at t equals 3. And so it gives us the position formula. So all you have to do here is plug in 3 and plug in 3 to the rest of the formula, and you get its position is 138. And now for B, it asks for its velocity at t equals 3. So if you're given the position function, you can take the derivative of this function to get the velocity function, right? And so once you do that, you plug in 3, and once you do that, you get that the velocity is 163. And so C, find its acceleration at t equals 3. We're just going to take the derivative one more time to get us this function here, and we're going to plug in 3, and once you plug it in there, you get 150. Let's look at implicit differentiation. And so this is dy dx or ddx, and that is the derivative of y with respect to x. And so in implicit differentiation, the function will not directly be solved for y. For example, it'll look like xy plus y squared equals 5x plus 9, instead of the normal functions we see where y is explicitly defined like y equals da 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 da. So the steps of implicit differentiation are, first you're going to differentiate each side of the function, and the derivative of y will be y prime in this case. So here we have y squared plus xy plus x cubed equals 9. And so when we differentiate this here, we get 2y times y prime, because anytime we differentiate a variable y, we're going to attach a y prime to it, plus xy. If you do product rule, you get y plus x times y prime. Again, we're taking the derivative of x here and leaving y alone, so we get y. And then here we're taking the derivative of y, which is y prime, and leaving x alone. And then the derivative of x cubed is just 3x squared. There's no y in that, so we're not going to attach a y prime. And then the derivative of 9, a constant, is 0. Now, we're going to collect all the y primes on one side. And here you may need to factor, so just keep that in mind. So we're going to move the y from here to the other side. We subtracted it here. And so we have the y primes on one side and the other terms here. And so we factor out the y prime from these terms, and then you divide this term to move it to the other side, and you finish solving for y prime, and y prime equals negative y minus 3x squared over 2y plus x. And so finally, related rates. So the steps of related rates are 1. Identify or solve for relevant quantities. 2. Write a formula that relates the two quantities. 3. Differentiate the formula with respect to t, which is time. And 4. Substitute known values and solve for the unknown ones. So we have an example here. A ladder is 15 feet long and is leaning against a wall. The base is pulled away from the wall at a rate of 3 feet per second. How fast is the ladder falling to the ground when its base is 9 feet? Okay, so we have an image here too. So we see that this is a right triangle, and automatically for these problems, if you see a right triangle, think of the Pythagorean theorem here. So here we have x, we have y, and this would be our c, but we've just replaced it with 15 already. So x squared plus y squared equals 15 squared. And we know that our base is 9 feet because that's what it's asking us to solve for. So we can replace x with 9 here as well. And so just by the Pythagorean theorem, we get that y equals 12 feet. And then we also know that x is 9 feet. And we also know the rate at which the base is moving away from the wall is 3 feet per second. And so that will be, since that's a rate, we're going to denote it as dx over dt. And it's dx because it's the base that's moving. If the height was changing, then this would be like dy over dt. And so now, basically, we're going to take the derivative of this Pythagorean theorem function here, which we see right here. So now we're going to differentiate the Pythagorean theorem function here with respect to t. And when we differentiate with respect to t, that means we're going to have to attach a dx dt to the x variable and a dy dt to the y variable. So that's why we get 2x times dx over dt plus 2y times dy over dt equals 0, since the derivative of a constant 0. And so now we plug in what we know. So we know x is 9 feet. We know dx over dt is 3 feet per second. We know that y is 12, and we're solving for dy dt. And so once you do a little bit of algebra, moving the terms to the right side and dividing, you get that dy over dt equals negative 54 over 24, which is negative 9 over 4 feet per second. So, to recap, in today's video, we've learned about the derivative function and shortcut rules, such as the power rule, product rule, and chain rule. We learned about implicit differentiation and how you can differentiate a function that isn't explicitly stated as y equals something. We learned about position, velocity, and acceleration and how they're all related to each other, how velocity is the derivative of position, how acceleration is the derivative of velocity, or the second derivative of position. And finally, we learned about related rates and how to solve equations where one variable is changing with respect to time. So that's all for today. Make sure to stay tuned for the next AP Calculus AB video, which will be a Chapter 3 review. Thanks for watching.